I am on a quest. I want to find out how to make software and hardware perform at their peak. I want to know how to make applications faster and more efficient. And while I'm at it, I want to have a little fun. Don't think I can do it? Just watch me. I'm Scott Moore, and this is the Performance Tour. Hey everybody, it's time again for another episode of the Performance Tour. I have just driven from Florida to Boston, Massachusetts, and I'm here in Burlington where we've just finished a Performance Tour live event. A little more intimate setting, but we had great feedback and great conversation, and believe it or not, some pretty good barbecue. Check it out. You know, we don't live stream the Performance Tour events because we want you to be there in person. I want to have conversations in it, let it be interactive, and I also want to meet you, shake your hand, and make sure you get some good food. So today, I want to help answer a question that I've been asked many times online. Scott, how do you scale performance engineering in a very large, say, Fortune 500 company? Some startups, maybe it's a little easier to get started where you have maybe one or two people and you're working on a single project. But what happens when you've got dozens of people working on dozens or even hundreds of projects every year? How do you scale that, keep it consistent, and keep some kind of sanity? And so I've got a lot of questions about that, and my guest has the answers, and that's on today's episode of the Performance Tour. Roy, thanks for being on the Performance Tour today.
Thank you, Scott.
So we've known each other for many, many years, and we have both seen a lot and done a lot in the realm of performance, and you specifically have worked for some of the largest companies in the world. Why don't you introduce yourself and what you've done?
Sure. So I'm Roy Reyna. I've been working with performance for over 20 years. And in that time, I've worked at Dell, I've worked at Dun & Bradstreet, I've worked for Nike, I've worked for Charles Schwab, and now with General Motors. In that time, I've learned a tremendous amount, not only just getting exposure to a lot of the technologies, but the evolution that's taken place in software development, you know, how software is released, how it's tested, the platforms that are used. Everything has changed, and evolving over that time has been exciting. So I've learned a tremendous amount. I've gotten into management through that time, and I've had the benefit of people teaching me a tremendous amount. I try to pass the baton every opportunity I get. So it's great teaching not only performance engineers, but also developers and other IT leaders the value of performance. You know, how can an organization best benefit from that?
So 20 years ago, we were all talking about the Center of Excellence, whatever that means to some people. And I've heard good stories about it. In my own personal case, my organization, we implemented it, I think, very well. We had it like a well-oiled machine, and it worked great, but everybody was doing waterfall, so that made it a lot easier. Talk about your experience with a COE in these large companies and what worked and then maybe what didn't work.
Sure. So Center of Excellence worked very well in a large organization. So thinking 20 years ago, the majority of the applications were developed using waterfall. But you know, thinking specifically at my time at Dell, we had an organization that was developing software for e-commerce. And then some were building internal applications for their sales force. Some were doing supply chain and manufacturing. So different types of technologies and different types of release cadences. And most were waterfall, but some were starting to get into agile. The COE worked very well because it allowed the teams that were responsible for performance across those organizations to have a group of people to rely on that would allow some insight into, you know, what are the what are the trends that are happening? What are the new tools? What are the, what is each team doing? What's working for them? And understanding who the experts are. We had people that were very knowledgeable of performance engineering, but tuning on .NET applications and IIS. And we had some that were very proficient in WebLogic, and we had some that were focused on mainframe. So there's a lot of different angles there, but the CoE was what brought it all together. And it's, you get to go to a group that is knowledgeable collectively across the board. And if you have challenges, you're able to seek help. That team can provide you some insight within the company. You don't have to go and search knowledge bases or whatever we were doing at that time. That was a great community.
We built it like an internal consulting group for our company. So it's a smaller company within a larger company, but it was any team anywhere could say, we need to think about performance. We know exactly which group to talk. We know who will know the answer to our question around performance, whether it's in infrastructure side, code development side, anywhere in the SDLC, we can count on these people will help us where we can't do this ourselves. So we treated it like individual little consulting engagements that lasted for weeks or whatever it was. You are still at large companies and you still have to deal with this, making sure there's some kind of standard across the board, that you get the same type of output, that people understand know how to do the same things when they're part of a performance engineering team. What do you do now? And what's working for you now, even though you may not call it a CoE?
Sure. So just looking internally at the team in my organization. So we have a team of about 20 performance engineers that are very relatively young compared to what I'm used to. In my past, we built performance engineering skills onto somebody that already had some foundation. There was systems engineers. I started as a server engineer on for Windows when I was at Dell. So I was infrastructure, was my background, but bringing in a DBA or a network engineer or just a strong software developer, but having some foundation to build on is really what I'm used to. Mm-hmm. Now, in my current organization, I've been there for about 2 years. And when I started, we were relatively young and we doubled in size. Since I started, we've doubled in size, and we have a lot of college hires. So people that have been in their career for less than 18 months. And we started training them on performance engineering. And what we found works is that we have leads that are responsible for mentoring and helping them grow. A lot of places you have leads that are taking on assignments themselves, and they have a sliver of their time to do the coaching and mentoring. What's worked for us is that we've had leads that have not taken assignment of projects. Their primary focus is helping bring up the rest of the team. And what that's done is that's accelerated the time it's taken for a new hire to become a proficient performance engineer. When I say proficient, there's years that it takes to become knowledgeable of all the technologies that you're testing, but to understand test design, to understand requirements gathering, to understand the execution and analysis. We're able to do that in 6 to 9 months, where I would have assumed before it would have taken much longer. And having somebody that's there to support those relatively young performance engineers has really proven beneficial.
Getting to where they can walk and start running in 6 to 9 months is great. Well, what does it take to do that? How do you get them there that fast?
So we've started explaining what the desired outcome is. We want to put this application through the same experience that it's going to be seen in production and beyond, and being able to understand the pieces that it takes to make that happen. From workload design or workload analysis to see what's happening on your applications in production. What are the most common paths through the application? How do you use a solution to go and reproduce that? And then you turn up the volume. Everything from the workload to the test design to the analysis after the test. There's different pieces there. But rather than them understand just one thing and we focus on that, the desired outcome is for us to be able to have some predictive performance results, to be able to allow your stakeholders to understand at varying load conditions, here's how the application is going to behave. And when we start with that as a desired outcome, everybody understands a little bit more. It sinks in, you know, as I'm doing scripting, okay, I understand how this rolls into the big picture, you know, and then as we're running different types of tests, you know, whether it's a load test, stress test, endurance, why are we doing those things? It's not just going through the paces and executing, but why are we doing this? What questions are there that we're answering through the tests that I'm running? And that allows a lot of what they're being exposed to sink in a little bit deeper, more quickly.
And how much mentoring do you have to do to make this possible?
It's pretty regular. You know, we're doing it daily. And what we're doing is a lot of times we're not doing it one-on-one. You know, we'll have somebody that asks a question, and then we'll bring a couple of people to look over the shoulder, or we'll hop on a call and do screen shares so that we're mentoring a small handful of people instead of just one. And obviously that expands the value of that time. But we're doing it on the regular, and it's something that is pretty time intensive at first. But the value is there. You know, we were seeing the results, and you know, we're seeing self-sufficient performance engineers pretty early on compared to what I would have expected.
That's awesome. That's awesome. All right. So speaking of large companies, which you are still at a very large company, and I'm trying to think of. I've been wanting to ask somebody in your position this question. When you take a company as large as what we're talking about, saying, okay, we're just going to adopt DevOps across the board. That's like taking a cruise ship and just twisting it around in 15 seconds. Could be a complete disaster. Can you talk about what it's like to try to adopt that across a huge enterprise and the major pitfalls to watch out for if companies are thinking about this now?
Sure. So at one of my previous companies, we tried this, and we went from having engagements where we had dedicated performance engineers that were assigned to own the performance of various projects. That was the model that we were delivering in. And overnight, we wanted to try to shift to this DevOps model. And the approach that was being suggested and that we were actually putting in place was that no longer were we going to have a performance engineer that was dedicated to that application. We were going to make performance everybody's responsibility. And what they were going to do was have, you know, on a team of 8 developers, performance was spread across those, you know, and so was quality, and so was security. So in that model, everybody's responsible for it. So in my opinion, nobody's responsible for it.
That's right.
Right? Nobody's accountable, you know. And what ended up happening was you have a mix of understanding of what performance is, of what security is, of what quality is, and whether or not they know it is a toss-up. You also have competing priorities for these engineers. So they've got to deliver features. And along with that, we've got to do the testing for functionality and performance and security. So naturally, some of the other, you know, non-functional pieces of that fall to the bottom of the priority list. And we had to constantly advocate to make sure that there was somebody that was championing performance along the way. So it did not work. The reason for that was because we really removed the safety net of having a performance engineer that was going to champion that that discipline across all of these, you know, each individual team. The way that we corrected, you know, the course correction there was to keep that safety net in place, so that we did evolve, you know, and put that model into place so that everybody was responsible for these pieces. But we also had somebody in addition to that squad that was assigned to drive performance and ensure that that was still being done. And I think the big mistake that we made was that assuming that out of the gate we'd be able to do all of these things, and in reality it probably takes several quarters, maybe several years to mature and strengthen those skills that those developers may not have. But it's a journey to be able to get there, and I think that you can do it successfully, but it's not something that's easy, and it's not something that you should expect to happen quickly.
Is it reasonable to expect a developer, mid to senior, to automatically think when they're writing code for features and functionality to be thinking about performance, to be thinking about security? Is it reasonable to ask them to do that up front?
I think that there's the pamphlet version of, yes, you can try to teach performance to a developer, and you can promote those best practices, and I think that does add some value. A developer who has seen things break and has been under the gun, under pressure, working to resolve issues that have taken down production. This is people that are working overnight. We've all done that. Those are the ones that are going to have a better understanding of what it takes to be able to do that. So I think you're going to get a range of results whenever you do expect that. Yes, I believe it's possible, but again, the expectations need to be modest, and then the best practices need to be advocated and promoted regularly, so that you do have some consistency in across teams, as you have the mid-level to senior level developer doing these things. What's working, what's not. Having that center of excellence conversation. Even though it's not going to be called a COE, having that communication channel open across the developers and that organization is something that would be helpful, and not only for performance, but security as well. What's working and what's not.
Can you name, just off the top of your head, can you think of a situation where you did find that, where you mitigated something, where performance testing just really saved the day and it was just an outstanding win? Because I think we need to hear more and more of those stories.
Yes, that's the bit of the challenge in the performance space, is if you have high performing software that's delivered, it's the credit goes to the developers. And if you have something that snags in production and there's an incident, it's on us, right? So,
not that we want that situation, but
no, but that's the way that it normally it works. So there's been several examples where we've done some work, whether it is optimizing code to be able to run on less infrastructure. We're making it more lightweight, and for at the time, the example I'm thinking of, it was a physical hardware that was in our data center, and reducing the footprint significantly saved us thousands of dollars, tens of thousands of dollars for a single defect. So there are those types of examples. Thinking about the cloud. The cloud world that we're in today, that type of cost savings can be tremendous, because a lot of times that's something that's an afterthought. Okay, yes, we're putting code out, it's performant, but it's taking a ton of cloud infrastructure. And, the monthly cost is not something that is always seen by the right people. So is it a priority or not? That's something that is a challenge for many organizations. But in terms of outages, there's been times where we have found defects that likely would have caused an outage on an e-commerce site. And for e-commerce sites, you can look at the revenue that you're seeing, in a given day, in a given hour, in a given minute, and quantify the value of not only the defects that you're identifying and resolving, but what's the value of the team. For a large e-commerce site, there's business cases that you can make that if you avoid a single defect, a single incident, you're paying for the team, like you said, for the entire year, and think about the training that you can justify by using that as a measuring stick. How do you grow your team? How do you, the training, and just overall, let's put a healthy performance culture and start with this performance team. And here's why. You're going to end up saving millions of dollars by doing so.
Yeah, and for an e-commerce shop, I know that somebody that works for the chief revenue officer will know how much that is per minute. They'll know how much you're losing if you're down by that much. Yeah. And then also, not just the outages, but if you improve the performance, you get more conversions. We've proven that just by 1 second of savings on an e-commerce site is 7 to 9% more conversions. Who wouldn't want that?
Right.
And somebody in your company knows what 9% would give you. And that is likely going to pay somebody's salary right there.
Everywhere that we've done similar work to that, knowing what the end user's doing and understanding the site abandonment and conversion rates, and then understanding the differences that performance makes there, it's a no-brainer. That's something that is such a powerful metric, and once you do see that, it becomes a priority, and that's a good thing. It's not that you're preventing outages. Now you're enabling your business, and that's something, just a very powerful metric.
Awesome. Roy, thanks for being on the show today. Always a pleasure to talk to you.
Thank you, Scott.
Have you back again.
Well, dude, thanks.
So there you have it, another episode of the Performance Tour, where we've talked about performance engineering, a little bit of barbecue, and a little bit of other stuff as well. If I don't see you till the next episode, this is Scott Moore saying thanks for watching, and I'll see you on the road.